Hi everyone, Easy Peps here, welcome back to my channel. Since some of you asked on how to apply this gommage effect on an animated mesh, I decided to make this fairly short tutorial that will explain on how to integrate the effect we built in the last series on an animated character. Now for this video I'm going to use an FBX character and an FBX animation. If you don't have one, I will provide you a link to download these two guys, and I will probably launch some Coffee page finally, so I will gather there all the tutorial material for download and also a few HDA in the future. Everything will be free as usual, but if you want to buy me a coffee, I do like coffee very much. And this time we won't build anything from scratch. I'm basically starting where we left off in the main tutorial series. So basically I'm taking for granted that you already completed the other videos. If you want to start from this, you could, and then fill in the gaps with the main videos. It's up to you. Now, since I built everything step by step in the last series, I can basically duplicate this one by one, change what is need to change, and move on. So I want to duplicate this scene piece first. Let's dive inside. Here, of course, I lost all the link. Let's see if, yeah. Let me set the project so we have the previous references to this, and it was Gommage. Yeah, so this was the old mesh. We want to import the new one, so we want to take an FBX character import, and here we want to choose the mesh on the FBX file, so this many-char, which is the mesh plus the skeleton, and let's see, yeah, it's huge but it's there, and also the animation, which is the walk. So animation FBX file, take the walk, and if we take a bone deform and plug everything, so the mesh, the rest pose and the animated one, we should already have the animation. Yeah, it's not looping because it doesn't loop by default for some reason. So on the timing here, if we put it in play, first I want to half the speed, so I will put 0.5 here, and if you click here you can see that it's tied to the time. What we want to do is to change here by frame, and if you look at the frame number now, you can see that it stops basically at 59. So basically to get a loop, all we want to do is that the counter here is set to 1 whenever it reaches 60. So we want to write two parentheses because we need to do multiple operations. The current frame -1, close one parenthesis, modulus of 59 because we need to hit one frame, otherwise there will be a small gap in the loop, and everything +1. And if you check the output now, you can see that when we reach 59, or rather 60, it reset, and if we play it, it's a loop now. So let's see the old mesh. It's actually bigger now. I believe the animation file actually scaled the final output, but I mean, that's not a problem. We want to maybe scale it a little bit, so we won't have to change so much the simulation parameter, and it should be like 10 times that, yes. And also we want to animate the translation of the mesh, because right now it's working in place. So I will use, let's say, 250 frame, and it will start at 0, and at 250 I know that a good value for the speed is 60 frame, and we want to do a linear animation, we don't want any easing. So let's see if he's doing some Michael Jackson shit. Yeah, a little bit, it should be quicker. Let's try 80. I will say this is fine. Also, we want to remesh this guy just like in the main tutorial, because this topology won't be good for the spreading effect. And we want to do it, of course, only on the mesh. So let's take a remesh node. We will plug the first output of the FBX character import, And here it escaped because the size is huge and it will be a massive problem if we do it on these sides with this guy. So we want to set the target size to, let's say, 0.5 and also the harden UV sim option. So let it compute and we should have something similar to the first tutorial, so something like this. Also, we want to fuse some point because we do have some splitting happening in the middle. This, of course, will depend on your meshes. And here it should be everything good as a default value. So we want to take also a point wrangle because we want to store some rest position. So we will write v at rest is equal to the current position. So basically we replace this to the first input and let me rearrange a few nodes. And here we should have the remeshed guy with some rest attribute that should be always the same, and we have. So take a null, we finish the first step, this will be out anim. So we want to go outside and let's rename this to scene anim. I will use this suffix for all the new nodes. So we do have the scene prepared. Come on, okay. And now we want to duplicate the FX part. So let's put it below the scene and this will be FX anim, dive inside. And here we can actually delete all the right side because we will have just one mesh this time. So delete these things. And here we want to replace with the scene anim and it was out anim. So this is the source mesh, which is the animated one. And here I don't want this remesh we were doing before on the mesh. And let's see, we don't need these things right here. And now if we go on the friction and display it, this is where we were calculating basically the noise for the spreading effect. So as you can see now it's moving because we were sampling the position. And if we replace it here with the rest we computed before, so here we will use the rest, which is a 3 float, and passed it to the position. Now it's not moving anymore. It's a way smaller scale because we computed the rest position before the scaling. So to have it back like before, you just want to scale this frequency by 10. So set it at 0.1 and we do have the same effect as before. So a static friction map. And actually, I'm not sure if the rest position is needed because we don't want to act on the animated mesh. Feeding this into the solver will be just a waste of computational power. So we actually want to time shift this to the first frame. So delete within a time shift and plug it between the mesh and the friction map. So actually now even with using the position we won't have that animation problem, but whatever. So on the main tutorial here we will defining some point that will act as a start for the spreading effect. In this case we have this guy walking and let's say that during his walk he gets hit 4 times in different parts of the body, and we will make it happen over time with not all the zone of the spread start at the frame 1, but for now let's decide the points. So let's clear all this point and let's create, let's say, 4. So I this guy, I want to enable the snap and let's say it will get hit on the arm, on the chest, then on the leg, and finally on the head. So here it should be everything good as it was the last time. And technically, if we display the old mask attribute, we should already have the spreading effect working, just as the last time. And we do. So let's go down the chain, and basically until this point it should be everything good as it is right now. Here we want to change something. First let's rename this to man anim source geo, and I want to save it in that subfolder I created for this video, so it won't mess up with my original file, and it's in here. So I will take this path and place it like this. And also let's change the end timeline to 250, so I won't get 500 here each time I drop down a file cache node. And let's save the sequence. So we do have our sequence, yeah. And here we were transferring the UV to this mesh from the original one. Here we want to transfer from this mesh to the original one, but not the UV. So here on the object merge, we want to take the out anim from the scene, so the animated guy over here. And this time this will be the destination. And from the source we want to take the two attributes we were using to drive the spreading effect, which were the age and the mask, which weren't on the vertices but on the points, so like this. So here we do have the animated mask on the animated mesh and also the age. And we do. Now, they are all starting at the same time. We don't want this. We want to be, we want the character to be hit over time. So we want to change something for the point and for the solver. Now, the way we're going to animate the spreading effect will be just by animating the points so they won't start on the mesh right away. It's sort of a half fake way to do it, and my advice is to or do it this way or find some similar way to work on a still frame. I mean, if you want to do some dynamic calculation for this to happen, do it. It will be a very cool technical exercise. But unless you plan to have something like 20 characters all get shot in different places at different time, it will be really overkill to do some dynamic computation for the hit location. So let's say the first hit will be the one on the arm, and it will happen at frame 50. So I will place myself at frame 50, put a keyframe over here on the Z, go back just one frame and put it something like 1000. So it will be way out of the way. Then let's say the chest shot will happen at frame 70, so the second point, keyframe here, go back one frame, 1000. So we do have 1 and 2. Then frame 80, it will get it in the leg, so 79, 1000. And last, let's say frame 85, it gets it in the head. So keyframe here, back one frame, 1000. So we do have 1, 2, 3, and 4 hits. The problem is now that even if we display the mask, and let's place here, you can see that here we do have the location starting at different time. But if we go on the solver and play it, we don't have any spreading happen, because the solver we are working on the previous frames, so for the solver everything that is at frame 1, it will be the reference one, then it won't get updated with the new points. So to make this work, we want to go inside the solver and change something in the wrangle dealing with the expansion, so the first one. Basically here we were taking the mask attribute. At frame 1, all the mask value are 0, so this is the reason the effect is not starting right now. Now, we actually do have the correct mask value. It's on this input 1. This is referring to the current frame outside the solver, so at frame 50 the points will start to appear. We can't replace this with the previous frame because this input don't provide the feedback on the solver, so this will completely kill the spreading effect. But we can plug it to the second input of the wrangle. So here, basically, after we said, okay, take the mask, divide by the friction, do whatever you're doing, check one thing, check if on the same point number, but on the other input, so the one coming from outside the solver, is there a higher mask value? Because that will be true only when a new point is added to the spreading group. And whenever that's true, use that mask value instead of the current one. So after this line, let's make some space. We want to say that if the mask on the other input, so we will use the point function, input 1, the mask, same point number, so ptnum, is greater than the current mask value, then the pt mask will be just that. And close the parentheses. And this is actually all we need to do. Let's go outside the solver and see if it's working. I have this cooking time which is not normal, but I'm not being very clean in the workflow. This is a very quick solution I came up since someone asked in the other videos, so there will be probably a better way to do this, but it should work. Let's see. And it is working. Okay, so we can save the new cache and see what we have on the animated one. Okay, let's see. Everything seems to work fine. Let's check also the age. Yeah, everything is working. So we're done with this bit. Let's go outside, hide this guy, and duplicate the pop part. So this will be pop anim, and dive inside. So we can delete the woman mesh and also yeah, this was for the erasing part. We can completely bypass this piece because this was for deleting the part between the two mesh for optimization. We don't need that. And probably for the cache of the source we should be already fine. Where oh, we need to update the one with the fx anim. Yeah, we do have the source for the particles, so let's rename this to pop anim source and save also this cache. So let's check the cache and it should be fine, and it is. So everything here should be fine. If you want to compute some other velocity, do it. I won't do it for the sake of this tutorial. We need to change something inside the popnet though. So dive inside the popnet and let's check what we have right now. So first off, we need to delete this pop kill, otherwise we won't get any particles. Let's see, we do have already something. It's pretty much working actually. There's not much we need to change over here. But if I remember correctly, we do have some wind pushing to the x-axis, so maybe that I want to change it to 0 and push it instead on the z-axis, so it will follow a little bit the mesh. Yeah, something like this. And one important thing we need to change is the collision with the mesh. If we go on the static object and visualize the collision guide, you can see that the collision mesh is not moving. We need to check use deforming geometry, otherwise it will refer only to the first frame, and keep in mind this will slow down the simulation a little bit. Nothing unreasonable, but it will be a little bit slower, as you can see. But now we do have the collision mesh moving. Let's see what we have. It should start around frame 50. Yeah, I would say it works. So let's go on the pop sim cache and let's call it pop anim sim, so we can save also this cache. A lot of caching today. And let's see what we have. what am I seeing? The age of the particles. Yeah, we do have the setup working. Here we were splitting the petals and the dust. And here is not finding the UV, but this was for visualization, so I don't care. Actually, it's not finding the petal geometry. Why? I need to update some path. I mean, it should be here since forever. Yeah, okay. So let's go back here and let's check it. And bypass this guy. This was all for visualization purposes, but I would say it works. And that's pretty much it for this video. I just used this time a sort of limbo instead of a backplate. And inside Karma, I'm bringing that plus the mesh coming from the FX anime we computed, so the one with the mask. And inside here, beside deleting the point wherever the mask reach 1, just as the previous video, I'm also computing some ID value on the PTNAM and some velocity and speed based on that ID attribute, just for the motion blur and both for the motion vector pass. The other time we didn't need to do on the mesh because they were completely static, so we computed the velocity only on the particle. And for the render, I actually bypass completely the dust part. I'm pretty sure I'm bypassing, the deletion, so I'm using all the particle for the petal, but this part is totally up to you, I mean. And that's pretty much also for the Karma render. The only difference is, of course, I updated the texture for the new mesh. I'm providing those two if you want to render with a coherent texture on the mesh. And everything else is the same. So I ended up basically with something like this. As you can see, there's something to deal with when you are seeing the back side of the mesh. Here I was conflicted again about cooling the back faces, but I mean, whatever, these are all artistic choices. The setup should work on some animated mesh, and as usual, I hope you found this video useful, and see you in the next one. Cheers!